Let's go ahead and try to solve this radical equation. Here we have the square root of the quantity x plus 7 minus 5 is equal to x. I need to first isolate the radical. To do that, I need to add 5 on both sides, and that will get me to here. I will have x plus 7 is equal to x plus 5. So the square root of x plus 7 is equal to x plus 5. Now, to get rid of a square root, I need to take both sides to the second power. That's just going to cancel out the square root on the left. Nothing exciting over there. So we just have x plus 7. Now, here's the part where students often make mistakes. They do not square this binomial correctly. Please, please, please do not tell me that x plus 5 squared is x squared plus 25. It is not. You cannot just square the first piece and square the second piece. You will be incorrect if you do that. Remember, that means x plus 5 times x plus 5. I know how to square a binomial in my head, but I'm going to go ahead and write this out so you can see it, so that we don't hopefully have this mistake over and over and over again on the problems. Here. So this will be x plus 7 equals x times x is x squared, and then that was the distributing there, and then x times 5 makes 5x, 5 times x makes another 5x, for a total of 10x, and then 5 times 5 is 25. So a lot of times students will forget that middle term there. The difference now is this is a quadratic equation. How do we solve quadratic equations? We get them equal to 0, and then we either solve them by factoring, or we use the quadratic formula, or we graph them. Or we have a variety of different methods that we've used to solve quadratic equations. Getting this equal to 0, I need to subtract x and subtract 7 on both sides. That'll cancel out over there and leave me with 0, and I will have x squared. Let's see, 10x minus x is 9x, and 25 minus 7 is 18, right there. So here I have the equation equal to 0, and then now I need to go ahead and just try to solve that quadratic equation. I'm going to do so by factoring. I'm going to erase some of this here, leave the original equation so I can test my answers here in a moment. I need to try to solve x squared plus 9x plus 18 is equal to 0 by factoring. Split it up into two binomials, x and x. I need two numbers that multiply to 18 that also add up to 9. That would be 6 and 3. And now I can set each factor equal to 0. X plus 6 equals 0. X plus 3 equals 0. Subtract 6. I'll get x equals negative 6. Subtract 3. And I'll get x equals negative 3. And I have what appears to be two solutions to this equation. Again, I could have used the quadratic formula to solve that once I got there if I was more comfortable with that, or I could have graphed it and just found where x squared plus 9x plus 18 cross the x-axis. The real solutions will be visible as the x-intercepts of the graph. But I chose to do it by factoring in this example. Make sure you test your solutions here, though. This is where you end up with extraneous solutions, where those are the solutions that come out of the algebra and they don't actually satisfy the original. You always need to be careful when you have variables on both sides of your equation. So let's plug these back in and try to test them here. We plug in negative 6 for x. Negative 6 plus 7 is 1. The square root of 1 is 1. And 1 minus 5 would be negative 4 on that side of the equation. I was plugging negative 6 in for x over here, so I would have negative 6 on this side of the equation. So this would produce negative 4 on the left side when I plugged it in, and negative 6 on the right side, which are not equal. So this is not a solution to this equation. We would call it an extraneous solution, but it did not satisfy the original equation. Let's test negative 3 and see what happens. Negative 3 plus 7 is 4. The square root of 4 is 2. 2 minus 5 is negative 3. So we got negative 3 on the left side of the equation, and when we plug negative 3 in on the right side of the equation, we also have negative 3. So since the two sides are equal, negative 3 does in fact equal negative 3. This is the one and only solution to this radical equation.